Okay, welcome to the next lesson in the Polynomials series. Today we're going to be talking about the Multiple Root Theorem. Okay, what does the theorem say? It says, if p of x has a zero of multiplicity m, then its derivative p dash x has a zero of multiplicity m minus 1. Okay, so let's prove this first, and then we'll do an example in another video. So the proof. So let p of x be a polynomial of nth degree. That means the highest power of x is n, with a root of multiplicity m at x equals alpha, where n is greater than or equal to m. Okay, so what does this mean in terms of a mathematical statement? So that means p of x is equal to x minus alpha to the power m, because we have m roots. It's a root of multiplicity m, so we have m of them, times by some other function, q of x. And the reason we times by this q of x is so that we can make up the degree to n, because if p of x has a degree n, and this has a degree of m, and remember m is less than n, we need to make up that extra to get to n. So we can say that the degree of q of x is equal to n minus m. But this doesn't really matter. Okay, now we can go ahead and differentiate both sides. So the derivative of p of x, so p dash x equals. Now here, you should recognize this as a product, so we have to use a product rule. So the product rule says we differentiate the first and times it by the second, plus the derivative of the second times the first part. So here, the derivative of the first is bring down the power m into x minus alpha to the m minus 1 times q of x, plus, now we differentiate the first part, we differentiate the second part, q dash x, and we leave the first part, x minus alpha to the m. Now, if we take out x minus alpha to the m minus 1 as a common factor, this is what we get. So if we take it out from the first term, we're just left with m q of x, plus, if we take it out from the second one, well, we have m of them here, so if we're taking out m minus 1 of them, we're left with just 1, so we have x minus alpha times q dash x. And then this is equal to x minus alpha to the m minus 1 times some function of x. So f of x here, that's just this expression, which is m q of x plus x minus alpha q dash x. And so here we've proven that p dash x, the derivative of p, has a root of multiplicity m minus 1 if the original function p of x has a root of multiplicity m. And that's the end of the proof. Okay, so in the next video we'll see how to apply this to a question. Okay, thank you.